And today we're going to start talking about something called substituents. What in the world is that? All right, so if you break this down, substituents comes from the term substitute. Okay, so let's take our nice 5-carbon chain. And how about if I put something here? Okay, so a substituent means in place of a hydrogen. So normally we would expect this to have, this carbon here to have 2 hydrogens, but it doesn't. It has 1 hydrogen and something else. So something else in place of an expected hydrogen. All right, now what is going to be important here is, now right now we're just going to talk about when we have extra carbons. So the first thing we need to do is we need to find the longest carbon chain. And right now that seems really easy. Okay, so look, 1, 2, 3, 4, 5. This is why I say get used to numbering the carbons. Well, what if you did this? What if you said 1, 2, 3, 4? Okay, that's actually not right. Okay, so we want to identify the longest carbon chain, and that's not always easy. But what we're going to do then is we're going to identify our substituents. And right now it's probably easiest if you do what I did and you circle them. Okay, so here I'm going to say 1, 2, 3, 4, 5 carbon chain. Okay, now identify the substituents. Now these are all carbon right now, and so we're going to have a number prefix, which we used in the last video, plus the suffix YL. Okay? So when we look at this one, it's easier. We could say, oh, and then there's the 1 carbon in the middle that's pointing down. That's a little bit clunky to say. So what we would do is we would say the 1 extra carbon hanging off the main chain. So 1, if you remember, would be meth. So this would be meth, and we put YL. Okay, so methyl. And then, so this is still a pentane because it's all single bonds, and it has this, so this would be a methyl, and we're going to call it a group. So that's what that is. Okay, now, generally, you're not going to have more than 4 carbons on there. So let's do another one. I'm going to draw a more complex molecule here. Okay, so now you can maybe see how it's a little bit more difficult to find the chain. Now if you watch me draw it, I kind of gave it away. But again, practice in pencil. So let's kind of identify our potential carbon chains. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6, 7, 8. All right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 is our longest carbon chain. So this would be an octane. Now let's circle our groups here. All right. Now, we have 1. So this is, so 1 is, we already said, a methyl. All right, now this has 1, 2, 3 carbons. It's kind of tricky when you kind of get into this. So 1, 2, 3 carbons. So this is a propyl group, which is a little bit different. No, it's not. Propane. So propyl there. So it's a propyl group. Now, because of this specific shape, where it's nice and symmetric here, this is actually called isopropyl. You've probably heard like isopropyl alcohol. So isopropyl alcohol looks like this. And if you remember me, and I love symmetry. So if it's very symmetric, if it's very pretty, generally you're going to put iso on there. Because this could be a little bit different. So this is iso. If a just standard propyl group would look like this. 1, 2, 3. But that's not what I drew originally. I drew this. So this is an isopropyl. Hopefully that helps. All right, let's try one more on here. I know my video is getting a little long. You're probably not with me. All right, so what if we have this? Okay. Now, here we can't, it's really tricky. So we have a ring. So we have a ring that's going to be, that kind of makes, it's not a chain, but that makes it a little bit easier because we have our ring, and after that we only have 1, 2, 3, 4 carbons. So our ring has 6 carbons. 1, 2, 3, 4, 5, 6 carbons. So this is going to be a hexane. And then this right here is our substituent. And we counted it as 1, 2, 3, 4 carbons. So that would be BUTYL. All right. Now, again, this is very symmetric and it's very pretty. So this is also known as isobutyl. Again, if it was all straight line, it would not be that. It would just be butyl. But an isobutyl, you can kind of remember because it looks like a chicken foot.